Welcome all. Today in building services, we will get to know about the technologies that is used to make a building a smart building. So first, IoT, that is Internet of Things. So we will know about the architecture of the Internet of Things. First one is the sensor, gateway, internet, cloud, analytics, and finally to the mobile app. So that is IoT is nothing but the interconnected physical device exchanging the information through the internet. And in terms of its application, smart lighting, water, HVAC, structure monitoring, parking, and the security. So next is about the artificial intelligence. So that is AI driven predictive maintenance. So AI analytics historical data, weather occupancy, power demand, equipment health, and its applications include the predictive maintenance, energy optimization, occupancy prediction, fault diagnosis, and demand forecasting. It works based upon the AI continuously analyzes the historical equipment data, and the pattern indicates the chiller is likely to fail soon, and the maintenance is proactively scheduled, and unexpected breakdown is avoided entirely. Next is about the digital twin. So that is the other technology that use it to make a building as the smart building. So a digital twin lets engineers see and predict building behavior without physically inspecting it. So that is in order to make that is we can create a virtual replica of a building in order to analyze the behavior and the performance of the original building or the physical building. So digital twin is nothing but the making the virtual replica of a building. So a continuously updated virtual replica of the physical building. Then live data feed, that is receives the real-time data streams from the installed sensors. Then building monitoring tracks performance of the every system remotely, and simulation test changes visually before real-world implementations. And facility and the renovation planning supports maintenance and the future upgrades. That is, it will be easy if we create a visual replica and analyze the behavior and the performance of the building. Next is about the energy management. There is smart energy management. There is peak load. So peak load management pairs storage with the real-time pricing data to actively cut cost. So the components of that smart energy management is solar PV, battery storage, smart meters, and the energy dashboards. So the demand response shift or reduces the load during the high tariff periods, and at a peak tariff. So the battery storage supplies the electricity to the buildings, and as the result, the grid power draw reduces, and the electricity bill will be decreased. So next, it is contributing to the sustainability, that is green building integrations, that is a lead Griha IGBC and net zero buildings and waste and water conservations and indoor environmental quality. So that is the lead Griha and IGBC. These are some of the green building certifying recognized institutions. So that is recognized green building rating systems. Next is about the net zero buildings, that is energy generated matches the energy consumed. Then waste and the water conservation, reduced waste generations and recycle water use. Then indoor environmental quality, that is better air quality, supports the occupant health. So next we will go through about some case studies. So that is Indian smart building implementations. Some buildings in India that have adopted the smart building technologies. So first one is the first example is the Infosys Mysore campus. So which is in Mysore, Karnataka. So it has of the smart HVAC systems for occupancy based coolings and energy efficient LED lighting across the campus, and water recycling systems reduce the fresh water demands, and solar integration supplements grid electricity. So these are the smart systems that have incorporated in the Infosys campus. Next case study is the Hyderabad International Airport. So it is in the Samsabad, Telangana. That is automated baggage handling systems and smart sensor-based terminal lightings and centralized building management systems and automated fire detection and the response systems. Next case study is the DLF Cyber City and GIFT Gift City. So DLF Cyber City, it is in the Graham. So it comprises of some smart technologies which include the centralized building management systems and smart parking with the guided allocations and biometric and card-based access control and real-time energy consumption monitoring. And in GIFT City, which is in Gujarat, so it is integrated command and the control center and district cooling systems for efficiency and smart utility metering across the city and continuous IoT based infrastructure monitoring. So next we will see about the evaluation and the future outcomes, that is advantages, challenges, comparison. So first is about the benefits, that is advantages of the smart buildings. So first is about it is categorized into three categories. So that is first one is the economic, another one is the environmental, another one is the social. In terms of economic, that is it lowers the operating cost, reduced maintenance and longer equipment life, lower energy bills. In terms of environmental benefits, so it includes the lower emissions, less water use, reduced waste and renewable energy integrations. And in terms of the social benefits, so better comfort, healthier environment, improved productivity and enhanced safety. So next is about the challenges in adopting smart buildings. So first one is the high initial cost, that is sensors, controllers and building management systems require the heavy investment. Second one is the cyber security, which is connected systems are vulnerable to attack. And third one is the complex installation, that is retrofitting older buildings is very difficult. Fourth one is the skilled operators needed, that is required trained facility management staffs and interoperability issues, that is different vendors, different protocols. So that is interoperability issues. And other one is the data privacy, that is occupant data must be protected. So next comes the comparison of the conventional building and the smart buildings. So there are some features where based on which the conventional building and the smart building is compared. So first feature is the lighting. So in terms of conventional building it is manual, in terms of smart building is automatic, that is daylight and occupancy based. And in terms of HVAC, the conventional building is manual and smart building is sensor based and the zone control. And in security, the conventional building is using the guards, and in smart buildings, AI plus CCTV analytics. In terms of fire safety, conventional buildings has only alarms, and in terms of smart buildings, automated multi-step response. And in terms of maintenance, so in conventional building it will be reactive, but in smart building it will be predictive, that is which is AI driven. In terms of energy use, so here in conventional building it will be of the high consumption. In smart buildings it is optimized consumption. In terms of monitoring, the conventional building the checks can be made only manually. In terms of smart building, real-time centralized building management systems. Then in terms of comfort, that is in conventional building it is a fixed setting, but in smart building is adapted to occupant and weather. Next is about the future trends, that is what is next for the smart buildings to be adopted. That is AI and the machine learning, artificial intelligence and machine learning, so deeper predictive automation and 5G connectivity, so it can be faster, denser and sensor networks. Then digital twins, so full life cycle visual modelings can be done by using the digital twins. And the net zero building, so balanced energy generation and use, and robotic and autonomous maintenance, so self-serving building systems, and blockchain and edge computing, so that is a secure, faster local data processing. Thank you.